So friends, welcome to this video lecture. We will today study the different computation of the different measures of central tendency and dispersion for group frequency distribution. I am your professor Dipojyoti Bhattacharjee from the Department of Statistics, Assam University, Silchar. So previously we had seen in our live classes how to compute the different measures of central tendency like the mean, median and mode, and also the different measures of dispersion like standard deviation, variance, mean deviation, etc. for when the observations are available as a data set but not as a group frequency, just a few raw data I have, and from there we have computed the different measures of both central tendency and dispersion. We will take a step forward and look at a group frequency distribution and try to understand how such computation is done for a group frequency distribution. Now friends, you see we have a data set like this, and here this data set we had been using earlier also, but then for new listeners let us have this. So this is an example of a group frequency distribution. A group frequency, the data is available in terms of class intervals like 2 to 4, 4 to 6, etc. These are called as the class intervals, and these are called as the corresponding frequencies. Now what is this? A researcher collects data for 3 months about the daily demand of rooms in a hotel. The data thus obtained are presented in the form of a group frequency distribution. So these are the demands per day for rooms in a particular hotel. Now in this hotel there were 4 days in out of 90 days, that is 3 months, when there were only 2 to 4 rooms were demanded, that is 4 number of days, such days when there are demands for 2, 3 or 4 number of rooms. 2 or 3 number of rooms, actually 4 will be considered here. So 4 to 5 number of rooms were actually demanded in 8 such days. 6 to 7 number of rooms were demanded in 12 days. So this is the way in which the data is obtained. From here we cannot say go back to the raw data, but once we have the raw data we can construct frequency distribution like this, and if we want we can change the class intervals also. Now this is called as the lower limit of the class, this is the upper limit of the class, and so these are the frequencies. So this way the data is presented before me in this particular way. So interesting thing that from raw data we can form this group frequency distributions, but from group frequency distributions if you tell me to go back to the raw data, I will not be able to go back to the raw data, so that information is lost. But this will actually provide you a more concise information, because it is very difficult to look at the raw data and understand about the data set. But here you can make an understanding like maximum number of days the demand is coming, because out of 90 days 30 days, that means about 1 month the demand lied between 10 to 12 number of days. So these such things are more vividly expressed when we go for the class intervals. Okay, now I think first they will ask me to compute the mean. Okay, so first we compute the mean. Now for computing the mean, what we do is that we write this and this, because this is provided to us. Now what happens, here starts the computation. We compute the mid xi. Mid xi is the middle value of the class interval. What is the formula for that? How did I get 3 from here? This is lower limit plus upper limit of the class by 2. So lower limit, first class, you see lower limit is 2, upper limit is 4, so 2 plus 4 divided by 2, so that comes out to be 3. So this is how we get 3 here, and then this is 4 into 3 equal to 12. So this is how we get this. Then we have 4 and 6, so 4 plus 6 divided by 2, so that is 5. So this is the mid xi. So this way I compute all the mid xi. These are nothing but the middle values of the classes. Now we compute a new column which we call as fi xi, because frequencies are notationally written as fi, means frequency of the ith class is fi, and the mid value is written as xi. So this is xi, and fi into xi, this column we create. So fi xi, just multiply the corresponding elements. 4 into 3 is 12, 8 into 5 is 40, then 12 into 7 is 84. Like this we compute this. Entire column gets over. Now we require to sum of some columns. First we require the sum of this column, and then we require the sum of this column. So here you see the summation of fi, which is also called as capital N, is equal to the sum of these frequencies, and the sum of these entire frequencies comes out to be 90. And here we have the summation Fi(xi). So Fi(xi) comes out to be here 904. So these are the two things, two columns for which sum is required. We don't require the sum of this mid xi column. Okay. Now what we do is that next formula for mean is x bar equal to summation Fi(xi) by n. N is summation Fi. So you may write summation Fi(xi) by summation Fi also. That is also a correct formula for the mean. Now what we do, we replace the value. Here we write the 904 because 904 is coming from here, summation Fi(xi), and summation Fi is, it is n is coming from here. When you replace this, we get 10.04. So this is the average of the number of rooms that are demanded in the hotel. And you can see that the average number of rooms demanded in the hotel comes to be 10.04. Next step, we go forward, we look at the computation of the median. So here we will compute the median of the group frequency distribution. Now let us look at the formula for median. This is the formula for median. It is written as capital M. This is equal to L plus n by 2 minus C by F into H. So let us understand the terminologies. What are the terms? N we are already introduced, but let us understand L. L is the lower limit of the median class, not any class, but median class, lower limit of the median class. And N is the total frequency. C is the cumulative frequency of the previous class. And F is the frequency of the median class. H is the class interval of the median class. So these are all the things, L plus n by 2 minus C by F into H. So these are the lower limit of the median class. N equal to total frequency. C is the cumulative frequency. Remember, previous class. Previous class means previous to the median class. Okay. So first you have to identify for this formula the median class. We will see how we identify the median class, and then we actually use the C is the cumulative frequency of the previous class. And then F is the frequency of the median class. That is the median class that we identify, that class frequency. And H is the class interval of the median class. There are cases when we have unequal class intervals. We may have unequal class intervals, but in that case, we will take the class interval of the median class only. Now we have a data set to compute the median. The data set is the same data set that we used earlier. That is, we have the number of demands for rooms and the corresponding frequencies. Here we prepare an additional column, and that is computation of the cumulative frequencies. So how to compute the cumulative frequencies we have already seen, but let us revise it. First value corresponding to the first class will remain the same, frequency will remain the same. Next value is obtained, that is 4 plus 8 equal to 12. Next is 12 plus 12 equal to 24. Next is 24 plus 14, that is equal to 38. 38 plus 30, that is equal to 68. And 68 plus 10, that is equal to 78. 78 plus 11, that is equal to 89. And 89 plus 1, that is equal to 90. That means this is the ultimate total frequency is also 90, if you remember, capital N. And last class frequency of the cumulative frequency will also be 90. In case it is not equal to capital N, if in case it is not equal to capital N, then you have to understand that you have committed some mistake when you have computed the cumulative frequencies. Anyway, so I think the cumulative frequency computation is over. Let me erase these marks so that it looks tidy. Okay, let us assume that we have computed the cumulative frequencies and we have got the third column of the table. Now, using this information, we will actually first find the median class. Now for the median class, we find that this is the formula for identifying the median class. We compute n by 2, because if you look at the previous slide, you will find that there is a formula for this median class and then this formula. And in this formula, you see n by 2 is very prominent. So that is what we require to compute in this median class. Okay. So first we compute n by 2. So what is n by 2? N is the total frequencies, that is 90. 90 by 2, that is equal to 45. So 45 is the value of n by 2. Now we see in this column where we reach 45. This is less than 45. This is less than 45. This is also less than 45. This is also less than 45. Now this class frequency, cumulative frequency is just greater than 45. So this class is my median class. Okay, this class is my median class. So we have our median class. So this is our median class. So we have our median class. So this is our median class. So we have our median class. So this is our median class. So we have our median class. So this is our median class. So we have our median class. So this is our median class. So we have our median class. So this is our median class. So we have our median class. So this is our median class. So we have our median class. So this is our median class. So we have our median class. So this is our median class. So we have our median class. So this is our median class. So we have our median class. So this is our median class. So we have our median class. So this is our median class. So we have our median class. So this is our median class. So we have our median class. So this is our median class. So we have our median class. So this is our median class. So we have our median class. So this is our median class. So we have our median class. So this is our median class. So we have our median class. So this is our median class. So we have our median class. So this is our median class. So we have our median class. So this is our median class. So we have our median class. So this is our median We had marked it, so extra marks let me delete. Okay, so this is my median class. So fine. Now let us proceed. Now, once we obtain the median class, now every other constant of the formula of median or parameter of the formula of median can be computed. L, lower limit of the median class. So, what is the lower limit of the median class? It's 10. So, I replace 10 here. Okay. N by 2 we have just now computed, it's 45. So, I write 45 here. C, cumulative frequency of the previous class. That means this 38. So, I replace here 38. And age is the class interval. And then frequency of that class, that is 30. So everything I put and then I compute, so I get 10.466, that is equal to 10.47. So this is the value of the group frequency, that is the median of the group frequency distribution, 10.47. And if you compare, you will find that it is very close. You can see just it is very close to the mean that we have computed earlier. So this is the mean is okay. Here we have the mean 10.04 and this is little bit more than 10.04. 10.47. Okay. So generally this is also a check. The median may be more than mean, median may be less than mean. All options are possible, but they will be close. They will not be very much far away from each other. If the data is very abnormal, then a different thing. But otherwise, the values will be close, so that you can suppose mean is 10.4, and then you will not get the median as say 18 point something, less likely. Okay. This is another check which you can have. Okay. Now let us proceed. Computed the median is over. Now let us compute the mode. So computation of the mode. This is the formula for mode. Let us try to understand what is the formula for mode is telling me. So this is the L. What is L? Let us have okay. Lower limit of the model class. That means there is some class which will be the model class, and we have to identify the model class. It seems FM, frequency of the model class. Okay. F1, frequency of the class prior to the model class. Okay. F2, frequency of the class succeeding the model class. So this is done, and age, class interval of the model class. So everything I have in the formula. This is the lower limit of the model class. This is frequency of the model class. This is frequency of the previous class of the model class. This is frequency of the following class, next class of the model class. Other things are already done, and age is the class interval of the model class. In some cases, there might be having different class intervals. The data may have different class intervals. So in that case, we will just pick up the class interval of the model class. So let us go back to the same data set and actually compute these. So let us have this. So this is the data set, which is same data set that we are using. Now how to identify the model class? That class which has maximum frequency, that class is the model class. So you see this, out of these, which is having maximum frequency. So this 30 here is the maximum out of the frequency. You don't have to compute cumulative frequency. Frequency will do. So this is the model class. You may have noticed that the median class and the model class are same. These may not happen always. In this case, incidentally or accidentally, it is same. But all cases you may not find it. Number 2, here you see all the class intervals are same. Means class interval 4 minus 2 is 2, 6 minus 4 is 2, 8 minus 6 is 2. That means I am not really, telling about the mid-x. I am telling the class interval. Class interval is upper limit of the class minus lower limit of the class. That is class interval. So you see 4 minus 2 is 2, 6 minus 4 is 2. All of them are same. So all the classes have the same class interval. So there is no confusion about it. Age is always 2. Now we start replacing L, lower limit of the class. So this is 10. FM, frequency of the model class. So that is equal to 30. F1, frequency of the previous class. So previous class is 14. So I am writing 14 here. And F2, frequency of the following class, next class. So that is equal to 10. These things twice, FM is already discussed, 30, and F1 is 14. So we have this multiplied by the class interval, which is 2. Class interval of the model class, that is this class. We don't need to look at the other classes. Whatever be the 12 minus 10, that is the class interval of this class, and that is equal to that I am replacing them. Now if you compute all 30, 10 plus 32 by 36, so this is equal to 10.889. So ultimately it comes out to be 10.89. So this is approximately 10.89. You see mode is little bit more than both mean and median. So this is how we compute the mode. Remember one thing, mean, median, mode, they are all having unit of measurement. So if your data is in number, these will be numbers. The mode is, this will be what is the actual unit? This 10.89 number of rooms demanded. Rooms demanded. Okay, this is not a standard unit, obviously I understand, but if your data is in centimeter, then mode will be in centimeter, median will be in centimeter, mean will also be in centimeters. That means they will retain the data set, the unit of the data set for which they are computed. So this is a very important finding. Now let us look at the computation for frequency distribution of the measures of dispersion. Now here we will cover three measures of dispersion. One is mean deviation, another is variance, another is standard deviation. So out of these three measures, or generally standard deviation is considered to be the best measure of dispersion. Others also exist. So this is the formula. You might have identified some term that this is the total frequency, this is the frequency of the ith class, this is the average. So you see in all this formula, mean deviation about mean, this is called as mean deviation about mean. I can have mean deviation about median also. I can have mean deviation about mode also. But this is more popular, so we have to use this, or we are using this. So for mean deviation from mean, you have to first compute x bar. So that is a very important. For variance also, you have to compute x bar. For standard deviation also, you have to compute x bar. So in each case, we need to compute x bar. If x bar is known to us, very good, or provided to us. In this data set, we have already computed x bar. Other than that, if it is a new data set, then we have to compute x bar before we start going forward with mean deviation, variance, or standard deviation. So look at the notation. Mean deviation is written as MD, variance is written as sigma square, and standard deviation is written as sigma. This is small letter sigma. Some people don't confuse with this. This is read out. This is also sigma. This is also sigma. This is capital letter sigma. This is small letter sigma. This one, not square. If you just, this is sigma. This is also sigma. But we will tell this as summation, and this we will call as sigma. Sigma. Okay. So this let us proceed forward. So we have the data set. Okay. So this is the data set that we have. Number of demands for rooms. So this is the thing. This is the frequency. We compute mid xi because we know that we need to compute the mid xi is required, because here I have a column for computing mean deviation, and then prior to that we will compute x bar. So I am not discussing computation of x bar, because necessarily video will get extended. We have already discussed how to compute x bar. N is the total frequency that will require, that value will require, and x bar 10.04 we have computed earlier. So you can go a few steps back and see how we computed x bar. So 10.04 is the mean. Now this is the two new columns that we are introducing here for computation of the mean deviation. One is, this is absolute. This symbol, these bars looking like this, they are called as the absolute value. Means whenever we compute something inside these bars, even if it is negative, we will write the positive value. And even if it is positive, then also we will write the positive value. That means we will write the magnitude, not the direction, not the sign, only the magnitude. So what is this mid xi? That means for this class, what is the mid xi? Mid xi is 3. And then average. Average remains same. So every value you see, the 10.04 is constant, but these values are changing. Why? Because the mid xi values are changing across the classes, but the average is remaining same. So you see 3 minus 10.04, it is minus 7.04. But because of this absolute symbol, we are writing as 10.04. This absolute symbol is also called as modulus, or in short mod. So we may call mod of x minus x bar. So 10.04. This is 5 minus 10.04. This is minus 5.04. So this is also called as, this becomes plus 5.04. 7 minus 10.04. So this is 3.04. This is plus. So this is, we are taking absolute value. Till this much the values were negative within the mod sign, but we have considered the positive values. From this point onwards, all values are positive. 11 minus 10.04. 0.96, 13 minus 10.04, 2.96, 15 minus 10.04, 4.96, and 17 minus 10.04, 6.96. So these we have obtained the value of xi minus x bar. We don't need to find the total of this column, but we proceed forward of multiplication 3 into 7.04. So you see, for this computation you require the support of at least a mechanical calculator. So this 4 into 7.04, so 10.16, 8 into 5.04, 10.32, sorry 40.32. Like this we go on, and for each term we multiply with the corresponding mid xi value and we get this. Once we get this, we take the summation of this column, summation fi xi minus x bar equal to 239.44. So this is fi xi minus x bar, and this is equal to this. Now we come to the formula of mean deviation. Mean deviation equal to 1 by n summation fi xi minus x bar, mod xi minus x bar, or absolute value of xi minus x bar. So we first multiply and then we take the sum. So you can see this activity here. We have not taken the sum directly. First we have completed all the multiplication, then obtains all the values and then taken the sum. Now divide by 90, so it gives me 2.66. So this is what we obtain from mean deviation, that is mean deviation equal to 2.66. So this is the mean deviation that we have computed. So this is a measure of dispersion in the data set. So this is how we compute the mean deviation. Remember that whenever you compute anything in statistics, so always, or any other science subject also, always write the formula. Because these actually, even if you know the formula, don't start with MD equal to 2.239.44 by 90. Just write the formula and then go a step forward. So every onlooker will understand how these things are. So already we had seen computation of the mean deviation about mean. Let us look at the formula of standard deviation. Standard deviation and variance, we have seen the formula earlier. They are actually connected to each other. The only difference is by a square root. If you take the square root, that is positive square root of variance, what you get is the standard deviation. So standard deviation can be also defined as the positive square root of variance. Standard deviation is denoted by the Greek letter sigma, and here is the formula, that is equal to 1 by n, that is total frequency, multiplied by summation of frequencies multiplied the square of the deviation. This is called as deviation of the mid xi from the mean. So this is the deviation, xi minus x bar is the deviation. So this is the square of the deviation multiplied by the corresponding frequency, and sum of all of that, and everything divided by the total frequency. Then take the square root to get the standard deviation. So computational standard deviation is definitely little bit difficult, but with the help of calculators and computers, this is just stones throw away. But this is very useful also, and this is also the best measure of dispersion. Let us look at the computation of the mean variance. So we have this data set, these class intervals, we have the frequencies, you know how to compute the mid xi. Now we compute the average, and the average, as we know, is 10.04, so that is x bar. Now we compute xi minus x bar. This we have already done in case of computation of the mean deviation, but there we took the absolute value. That means we have taken the magnitude only, not the direction, not the sign. Here we take everything, like we get x minus x bar. So 3 minus, for this class mid xi is 3, minus the average 10.04, so that is minus 7.04. Next is 5, this is the mid xi value 5. Mean will remain the same, minus 10.04, so 5.04. 7 minus 10.04 minus 3.04, like this we get. So some values we get negative, after that we start getting positive values. So this will happen because you are taking the deviation above the average. So some values will be less than the average, some mid xi values will be more than the average. So this will be a combination of plus and minus. And if you take the sum of this column, in fact we don't require it for computation, but our teachers used to say that you should take the sum of these columns, because the sum of this column will be equal to 0. In case if it is not 0, that means you have committed some mistake while you have done the computation. Because you see these values, if you add up negative values, these are all negative values and these are all positive values. They are not same, but their sum will be, this will be negative sum, this will be a positive sum, their value will in fact be exactly the same, and when they are added, one is positive, another is negative, so they will eliminate each other, creating a 0. Now, sorry, next step we calculate the square of these values. Minus 7.04, square of that is 49.56, minus 5.04, square of this is 25. So this way I get the square of these values. All the values are squared up. So when values are squared up, they go big in size, so then magnitude has increased, you see. and then multiply with the corresponding frequencies. That is, second column now becomes active. Okay. Information from the first column is stored in mid xi, and second column still now we were not using it, but this is the only time that we are using the second column. So 4 into 49 point sorry 56 is 198.24. 5 into 25.40, so this is 203.2. Like this we go on computing these values, and then we take the sum of these values. Okay, so sum of these values come out to be 961.66. Now we know that capital N, that is total frequency, is equal to 90, and this is the formula of variance. Sigma square equal to 1 by n summation I goes from 1 to k, that is number of classes, fi xi minus x bar whole square. So this is the formula. So you see, I have already computed the value of fi xi minus x bar whole square, that is 961.68. So this is 961.68 by 90. So when you get it cancelled, then you get 10.68. So this is 10.68. So this is the value of sigma square. So sigma square equal to 10.68. So this is sigma square, and then this is the variance also. So remember one thing, that if your data is in centimeter, sigma square will become centimeter square, because here you see, here you have a square term. The xi minus x bar will be in centimeter, but this square will make it centimeter square. That means here, if it is the 10.68 rooms demanded square. So you may find it little bit difficult to interpret what is the meaning of this particular unit, rooms demanded square. So this is one problem mainly that exists with the variance, because it changes the unit of measurement. So in fact, if it is say centimeter data, then centimeter will get converted to centimeter square. Centimeter is distance, centimeter square is area. So your distance becomes converted to area when you take the variance. This is really very funny. So to avoid this problem, we introduce the standard deviation, which is the square root of the variance. So if your data is for after variance, if it becomes centimeter square, as soon as you take square root, this will get cancelled, and ultimately you end up in getting the centimeter. So this is equal to under root 10.68, 3.26. So this is data becomes like centimeter. So this is 10.26 centimeter. Sorry, 3.26 centimeter. So this actually sums up the computation of the standard deviation. So with this, we actually end up computing the mean deviation, about mean, the variance, and the standard deviation of a particular grouped frequency distribution. Now, once you have done it, then the question arises that how to compute the coefficient of variation, because coefficient of variation is a very important measure. Remember, the coefficient of variation is used when you have data set with different units of measurement. So this is actually helping you to compute the CV. So CV, how to compute? The formula for this is standard deviation by mean into 100. That is, CV is equal to, CV equal to, formula if you want to write notationally, sigma divided by x bar into 100. This is actually, since mean generally is more than the variance, standard deviation, so mean comes in the denominator, and it is expressed as a percentage of how much variation in terms of mean. So some people interpret in this way also. So already we have computed the standard deviation as 3.26. We replace it here, and if you remember, we have computed x bar earlier, which comes out to 10.04. So we replace it here, and then multiply by 100 to compare, get the value of 32.47. Though for these data sets, standard deviation is a good enough measure, and CV is not directly required. But when you want to compare the variation between two different data sets, try to get that point. When you want to compute the variation of two different data sets having different units of measurement, if they are having similar units of measurement, then fine, you can use. If the ranges are different, then you should not use. For example, what do you mean by ranges are different? Ranges are different means, suppose I take the T20 captain is these days Surya Kumar Yadav. So Surya Kumar Yadav's betting runs scored in last 10 innings I have. Okay. Then in the tail ender is coming Arshdeep Singh, who sometimes have to bat because all the batsmen might have got out. So his score runs I have in his last 10 T20 innings. So what I have, I have SKY, it is Surya Kumar Yadav's last 10 innings T20 runs average I have. Forget about not out, let us consider all at par out or not. Similarly, I have 10 last 10 innings of Arshdeep Singh. Now, when I compare the variance or the standard deviation, and I want to compare between Surya Kumar Yadav and Arshdeep Singh. Now they are having same unit of measurement, because unit of measurement of standard deviation of Surya Kumar Yadav is runs. Unit of measurement for the runs scored by Arshdeep Singh is also runs. So that way unit is not creating a problem. But you see the runs scored by Surya Kumar Yadav, who is one of the leading batsmen of the team, will be more. Means he will someday he will score 50, someday he will score 12, someday score 0, another day he scores 67. That means he will have a large range of scores or large range of possible data. However, Arshdeep Singh hardly gets any chance to bat, and if he gets, he has to play very few balls and may get dismissed very, because he is not known for his batting skills. So his runs will be 2, 7, 5, 16, like that. Means very less runs, and also dispersion might be little bit more. So in such cases also, we should not compare them directly by using a variance or a standard deviation. But in such cases also, when even if the units are same, since the ranges of the spread in the data set is different for the two players, so we will use the coefficient of variation to find out who or which player is more reliable. So less CV means less variation, less variation means more reliable. So in this particular computation, CV might not be very important, but when you have different types of data set, having different units of measurement, or even same units of measurement, but a varied data set in terms of its range, then coefficient of measurement comes indeed. So this is what I was supposed to offer in this particular presentation, and we have accomplished them. Let us take a revision of all the things that we have studied today. We have studied about the mean, the median, and the mode, and their computation for a group frequency distribution. And then we have studied three measures of dispersion, that is mean deviation, variance, and standard deviation, that also for a group frequency distribution. And then we had studied about the importance of the coefficient of variation, and we have also seen how coefficient of variation is computed. Thank you for watching the video. Please keep on visiting the channel for more videos in the similar lines. Thanks a lot.